Today we are going to discuss about matrices. So in previous class 10, we already discussed about the matrices. So matrices is a rectangular array. Okay, that means A equals to A11, A12, A13 up to A1n. Similarly, A21, A22, A23, A2n, AM1, AM2, AM3, AMN. This is a m by n matrix. So now we know what is the row matrix, what is the column matrix also, and we also done interest in the addition of the matrix, the subtraction of the matrix, and the multiplication of the matrices. Now we are discussing some important types of the matrices, the new types of the matrices, that is null matrix. So null matrix means all the elements are 0. So when all the elements of a matrix are 0, it can be square matrix, it can be rectangular matrix, what may be. Okay, this is a 2 by 2. You can write also here 0, 0, 0, 0, 0, 0. So this is a 2 by 3. So 2 by 3 means rows into column. So rows into column. So this is the null matrix. So when all elements of the matrix is 0, this is called null matrix. Now diagonal matrix. So what is a diagonal matrix? Diagonal means when only the diagonal elements are there. When the only diagonal elements are there, this is called diagonal matrix. When only the diagonal elements are there. Now scalar matrix. What is a scalar matrix? Scalar matrix is a square matrix and the diagonal elements is not 1. Any number without 1. This is called scalar matrix. So scalar matrix means it is a square matrix and all the elements only diagonally without 1. This is called scalar matrix. Now identity matrix. So what is the identity matrix? Identity matrix is only square matrix and diagonal elements are 1. Okay, this is called identity matrix of 2 by 2 and it is denoted by I2. So I2 means 2 by 2 identity matrix. Similarly, if I am denoting I3, that means it is a 1 0 0 0 1 0 0 0 1. It is a 3 by 3 identity matrix. Okay. Now equality of matrix. Equality of matrix means A equals to B to matrices equality. A equals to B when the same order is there and corresponding elements are equal. So if the order of A is 2 into 3, then B also 2 into 3, then we can say that they are equal matrix. Okay, then we can equal each element of A to each element of B. This is called the equal of the matrix. This is called the equality of the matrix. Now, next part. In first exercise, we only see that in first exercise, there is this problem of some easy sums that is we are already previously done. Okay, that means in class 10 you already done the first exercise. So I am now discussing about the second exercise. This is the transpose of the matrix. So three things we have to learn in class 12. Number one, transpose of matrices. Number two, inverse of matrices. And number three, that is row or column operation on matrices. So these three things we have to learn now. So today we are going to discuss about the transpose of the matrices. So what is the transpose of the matrices? See that. So transpose. So transpose means if A is a matrix, then A transpose, we can write capital T, we can write small t, we can write A dash. So all these are transpose, okay? All these are mentioning transpose. So A is a matrix and A transpose means changing rows into columns or columns into rows. So that means you have to change the rows into columns and columns into the rows. That means A transpose. Now, for example, see that if A equals to 1, 2, 3, 4 is 2 by 2 matrix, then A transpose equals to 1, 2, 3, 4. See that? This is the first row, this is the second row. Okay, I am changing the rows. This is the first row and this is the second row. Okay, so when we are changing the rows into columns or columns into rows, then we are saying that A to A transpose. So now we are using some properties on the transpose which are very much useful for doing the sums. Now we are discussing about that. Properties. In number one properties, A transpose equals to A. That means if we take transpose, then we get the same result. For example, if A equals to 1, 2, 3, 4, A transpose equals to 1, 2, 3, 4. Now again transpose. That means 1, 3, 2, 4. That means this is A. So we can say that A transpose equals to A. Okay. Put it down a bit. Now, second one, Very easy. This is A transpose plus B transpose equals to A plus B whole transpose. Okay. Wait, same order. This is the thing here. Same order. Okay. Number 3. AB transpose. This is very important. AB transpose equals to B transpose A transpose. Okay. AB transpose equals to B transpose A transpose. AB defined. AB defined. When AB is defined, then we can apply this property. Now we are going to start some exercise problems. See that. See that in number 16 of 3, 1, AB is given, A equals to given 2, 1, 3, 4 and B equals to given 1, minus 2, minus 1, 1. And you have to find or verify that AB transpose equals to B transpose into A transpose. So firstly, see that I am finding the AB. So AB means simple multiplication, A and B, 2 by 2 matrix. So after multiplication, you get this one. Okay. 1, minus 3, minus 1 and minus 2. So AB transpose equals to 1, minus 1, minus 3, 2. Okay. Now, in right hand side, see that B transpose into A transpose given. So B transpose means 1, minus 1, minus 2, 1. And A transpose means 2, 3, 1, 4. So that means B transpose into A transpose, that means 1, minus 1, minus 2, 1 into 2, 3, 1, 4. Now multiply on the multiplication rule. We get 1, minus 1, minus 3, 2, which is same as AB transpose. So now we can say that AB transpose equals to B transpose into A transpose. Okay, this is verified. Now next one. Now see that in number 21, A equals to given 1, 2, 3, 2, minus 1, 5. B equals to given 2, minus 1, 1, 3, 5, minus 2. So A plus B equals to normal addition. So 1, 2, 3, 2 minus 1, 5, 2 minus 1, 1, 3, 5 minus 2. If we add, so equal matrix is, the elements are same. So you easily add it. So 3, 1, 4, 5, 4, 3. Okay, this is a 2 by 3 matrix. Now transpose of A plus B, that is row into column, column into rows. That means 3, 1, 4, 5, 4, 3. That is 3 by 2 matrix. Similarly, we are finding the A transpose plus B transpose. And we have to verify these two values are equal or not. So A transpose plus B transpose equals to 1, 2, 3, 2 minus 1, 5 plus column wise 2 minus 1, 1, 3, 5 minus 2. That means after addition, equal matrix, we can add. So 3, 1, 4, 5, 4, 3, which is same to same as A plus B transpose. So we can say that A plus B transpose equals to A transpose plus B transpose. Note it down all of you. Now we are going to discuss about symmetric and skew symmetric matrices. Symmetric and skew symmetric matrix. So what is the symmetric and skew symmetric matrix? See that. So symmetric means Aij equals to Aji. That means A12 equals to A21, A23 equals to A32, A13 equals to A31. This is the main thing of symmetric matrix. Symmetric matrix mainly of order 3. So that means, for example, see that it is a symmetric matrix, that is 1, 6 minus 5, 6 to 4, minus 5, 4, 3. Now, one more thing I am telling, this is upper triangular matrix and lower triangular matrix. So what is the upper triangular matrix? Upper triangular matrix means when the upper portion is from only the numbers. This is the upper triangular matrix and this is 0. Okay, this portion is 0 here. For example, I am writing here 1, 2, 3, 0 to 1, 0, 0, 4. So that means this is a upper triangular matrix. Okay. Now for the same thing, lower triangular matrix, this is 1, 0, 0, 1, 1, 5, 2, 5, 3. So see that this is a lower triangular matrix. So when these three numbers is there, sorry, this is 0. So this is called the upper triangular matrix and lower triangular matrix. So check these two only for here and which are same values. See that 6, that is A21 and this is A12. This is equal. Similarly, A23 means A23. This is 4. And here see that A32. This is 4. This is the equal. A13. This is minus 5. And here 31 is minus 5. This also equal. So these are called the symmetric matrix. So in transpose part, we can say that in transpose form, we can say that A equals to A transpose. If A equals to A transpose, then we can say that this is a symmetric matrix. If A equals to A transpose, then we can say that this is the symmetric matrix. Now, skew symmetric matrix. So for the skew symmetric matrix, Aij equals to minus of Aj. So Aij equals to minus of Aj is called skew symmetric matrices. So that means A12 equals to minus of A21. A23 equals to A minus of A32. A13 equals to minus of A31. So this is the skew symmetric matrices. For example, we can say that 0, minus 1, minus 2, minus 1, 0, minus 3, minus 2, minus 3, 0. So now see that here, sorry, this is not minus 1, it's 1, 2, 3. So see that this is the pattern. Okay, that means A12 is the minus of the others. Okay, A12, that means this one, and minus of A21, that is 1. Similarly, for A23 means minus 3 and here 3. And last one also same. So that means when Aij equals to minus ji, then we can say that this is a skew symmetric matrix. Now in transpose form, that means A equals to minus A transpose. A equals to minus A transpose. So A equals to minus A transpose, that means this is called skew symmetric matrix. Okay. Now one important property in property or theorem, we can say that is A equals to half of A plus A transpose plus half of A minus A transpose. So this is the theorem or property we are using for the symmetric or skew symmetric matrices. So if A is a square matrix, then we can say that A can be expressed uniquely as a sum of symmetric matrix and a skew symmetric matrices. One more thing I want to tell, A into A transpose equals to I. This is a unique property. This is A into A transpose equals to I. This is the identity element. Okay. That is 2 by 2 or 3 by 3 only. For only the square matrices. Now, see that. Now, we are going to discuss about the sum of the symmetric and skew symmetric matrices. Now, A equals to given 3 minus 4, 1 minus 1. Okay. Now, A transpose equals to 3, 1 minus 4 minus 1. Now, A plus A transpose equals to 6 minus 3 minus 3 minus 2, and A minus A transpose equals to 0 minus 5, 5, 0. Now, if we do that, that is A plus A transpose, that means 2P. Okay. If A equals to P, if we take by theorem, you can check by the theorem. So, that is P equals to 1 by 2 A plus A transpose, and Q equals to half of A minus A transpose. So now P equals to half of 6 minus 3 minus 3 minus 2, that is 3 minus 3 by 2 minus 3 by 2 minus 1, and Q equals to 1 by 2 0 minus 5, 5, 0. That means 0 minus 5 by 2, 5 by 2, 0. So now here we can express that is A in the form of P plus Q. That means, so A equals to 3 minus 3 by 2 minus 3 by 2, 0, minus 1 plus 0 minus 5 by 2, 5 by 2, 0. So this is the expression which we are find. So this is the sum of the symmetric and the skew symmetric matrices. So A equals to the sum of the symmetric and skew symmetric matrices. Now this portion is completed. If any doubt, you can ask me. Okay. In next class, we are going to discuss about the inverse of the matrix. Thank you, all of you. Take care. Bye-bye.